Let us solve these questions based on some special series. Now, if we notice this first example here, this is not an AP clearly because this difference is 6, then this difference is 8, this difference is 10, and this is 12, right? These differences are in AP 6, 8, 10, 12. If I can make a series of this will be an AP, but this given series is not an AP and it is clearly not a GP. So I will do a little manipulation that you need to learn here. I will write this as 5 plus 11 plus 19 plus 29 plus 41 and so on, n minus 1th term, then the nth term. I'll write it like this. Okay, now I am going to write this sum once again. Okay, but I will start writing from here below this second term. So 5 plus 11 plus, I am writing the same series the second time, but I have just shifted the first term towards right. Okay, one step towards right. So I haven't changed anything in this series. I have just rewritten it in a different way, slightly different way, right? So a n minus 1 will come here and then the final term will be a n. Now I will subtract these. Now you will know why I have been doing that. I am subtracting this from this. So I'll have 0 here, 5 here, plus. Now I will write these terms. Which terms? These differences inside this bracket, because these differences will form an AP. We have just noticed above, right? This will be 6, this will be 8, this will be 10, and then 12, and so on. And the last term will be an minus 1, and then this term, okay, minus an. So this is the difference that I have written. On the left hand side I have got 0. So let me bring this an on the left hand side. So I can say an is equal to 5 plus sum of this AP. Okay, now if I ask you how many terms are there in this AP, how many terms are there? There are n minus 1 terms in this AP. How do we know that? We know that if you just notice this sum, this first one, okay, this one, how many terms were there? There were n terms, right? We need to find sum up to n terms, so there were n terms written here. These are n terms, okay. And if you see this AP here, there is a term corresponding to every one of these differences, right? And how many are these? These are n minus 1. Why? Because we have just excluded this from out of these n terms. So these are n minus 1 terms corresponding to which there are n minus 1 terms written here in this bracket. So I hope you know that this AP has got n minus 1 terms. Okay, rest of the things we already know, that the first term is 6, common difference is 2, number of terms is n minus 1. So let me simply write the sum here, n minus 1 by 2 twice of first term plus n minus 1 minus 1 into d, that is 2. Okay, right? So this will be the sum of this AP. And let me close this bracket here. I have already taken this on the left hand side. Now I will get my nth term or an. So an is equal to 5 plus 2 can be taken common and can be cancelled with this 2. So this 6 into n minus 1 will become 6n minus 6, and this n minus 1 into this n minus 2 will become, let me write it like this, then I will simplify it. So 5 plus 6n minus 6 plus n squared minus n minus 2n plus 2, and it is equal to 5. This is n squared 6n minus 3n, so total 3n, and minus 6 plus 2, so minus 4. Okay, so it came out to be 5n squared plus 3n minus 4. Now let me write it somewhere else. This is plus here, right? So this expression is n squared plus 3n plus 1. This is my nth term. I am going to write it somewhere else. N squared plus 3n plus 1. So nth term that I've got is n squared plus 3n plus 1. Now I will apply the summation, okay, to find the sum. Sum up to n terms is, if I take the summation variable, let us say k, okay, and I take it from 1 to n, and then I have to write the kth term here. So let me write it like this: k equal to 1 to n, kth term will be k squared plus 3k plus 1. And we know that we can separate these terms because these are separated by plus sign, hence sigma can be written like this: k equal to 1 to n here, k squared plus k equal to 1 to n 3k plus k equal to 1 to n 1. We know that this sum of squares of first n natural numbers, this is sum of squares of first n natural numbers, and it is equal to n into n plus 1 into 2n plus 1 by 6. This is 3 into 3 I can take outside, right? This 3, what I am doing is I am taking this here. Now this is sum of n first n natural numbers, so 3 I have taken outside, and sum of first n natural numbers is given by n into n plus 1 by 2, and this is 1 plus 1 plus 1 plus 1 written n times, so this is n. Okay, now simple manipulation part is left. Let us take some of the things common. So I can take n common from all of these, right? So the first term will become product of these two, right, in the numerator, 2n squared plus 2n plus n plus 1 and divided by 6. N has gone outside, so the numerator will be 3n plus 3 and denominator is 2, and here I'll have 1. Just one more step of simplification, then we will see the result. So it will be 2n squared plus 3n plus 1 here, right, this one, and this will get multiplied with 3. I am taking 6 as my LCM, right? So 9n plus 9, and I'll multiply this with 6, so in plus 6 divided by 6, and it is equal to n into 2n squared 3 plus 9 12n, 1 plus 9 10 plus 6 16 divided by 6. And you can see that 2 can be taken common and it can be cancelled with this 6, so I'll have 3 in the denominator. It will be n squared plus 6n plus 8. This can now be easily factorized as 4n plus 2n, right? So in factorized form, this will be, I am just writing this quadratic that is inside the bracket as 4n plus 2n plus 8. So if I take n as common, it will be n plus 4. If I take 2 as common, it will be n plus 4. So this is n plus 2 into n plus 4. How do I write this here? N into n plus 2 into n plus 4 divided by 3. So this will be the sum. Okay, I hope this was not very complicated for you. This is a pretty simple question. It just needs a lot of space to solve this. The space I had provisioned for it was a little lesser. Otherwise, this question itself was very simple. You just have to separate sigma in this form, then you should memorize these formulae and just simply put it here. Now let us do this question. Find sum to n terms of series whose nth term is directly given, right? So if an is equal to n into n plus 3, then what will be ak? What is this? This is n squared plus 3n, right? So what will be kth term? It will be k squared plus 3k, right? Why do I write kth term? Because I do not want to take summation variable as n. What I'm saying is I need to find sum up to n terms, so I'll write it like this in sigma form. So I'm taking k as my summation variable. K will go from 1 to n, okay? And here I need to write the kth term. If I had taken n as my summation variable, then the upper limit is also n, so that would not be very appropriate. That is why it is always advisable that you take kth term or rth term here and then take k or r as your summation variable, which is very simple also, because once you know the nth term, you just have to replace n by k here, and now this looks very good. This is mathematically correct statement, okay? So now I will write it like this: k equal to 1 to n k squared plus 3k. Now let me separate these terms here itself so that we can save a lot of space. Okay, so this can be written as k equal to 1 to n k squared plus 3 I am taking outside of sigma, k equal to 1 to n and then k here, okay? So this is sum of squares of first n natural numbers. It can be written as n plus 1 2n plus 1 divided by 6 plus this is 3 into sum of n natural numbers, so it can be written as n into n plus 1 by 2 here. Now if you see, n into n plus 1 by 2 can be taken as common. This simplifies the calculation a little bit. What I am left with is 2n plus 1 by 3 in the first term, and in the second term I am left with 3 here. So this is n into n plus 1 into, this is 2n plus 1 plus 9, so 2n plus 10 by 3, and 3 into 2 in the denominator will give me 6. If you see, 2 can be taken common from this bracket, so let me take it common from this and write 3 here. So n into n plus 1 into n plus 5 by 3. I have taken 2 outside and cancelled this 6 with that, and I am left with 3 here in the denominator. So the answer is n into n plus 1 into n plus 5 by 3. I hope you have understood this question very well. So these were the examples of exercise 9.4. We will do the exercise in next lecture.